DrMBalmer channel. So, as you might guess from what you are seeing currently, this video is about this. It's the Nitecore UMS4 charger. It's the newest charger from Nitecore of this kind that I could find. So yeah, this was bought from AliExpress, and the price, including shipping, was yeah, let me check what the price was. Yeah, so $27.24 US after rebates and coupons. The base price was $31.65 US. So it looks like this in the classical Nitecore yellow-black colors. It has 3 amp speedy charge on a single slot max output. So it's not 3 amps times 4, unfortunately, but 3 amps on one single slot is pretty high as well, and perhaps you shouldn't charge with 3 amps on one single cell unless it's a very high capacity one. It's claimed to be intelligent, USB, 4-slot, and a superb charger. So I haven't opened this box yet, so I know as little as you at the moment as to what's inside here, but I did validate the QR code and on the Nitecore website, and it did validate. So it's compatible with different chemistries of lithium cells, IMR, lithium ion, and LiFePO4 in these sizes. It's also compatible with the nickel metal hydride and nickel cadmium cells of these standard sizes. Worthy of note is that there are no 9-volt cells listed here. So yeah, it's automatic high speed, real-time information display, specially optimized charging program for IMR batteries. Exactly what that means, I don't know at this point. Also, it has over-discharged lithium-ion battery activation and IMR battery restoration. Multiple charging safeguards. So, as an input, we can choose either 5 volts, 2 amps. So that's, in that case, 10 watts if you have a standard 5-volt charger input, or 12 volts at 1.5 amps, that's 18 watts max. So if you have QuickCharge, then you will be able to charge faster. Output is 4.35 volts or 4.2 volts, and 3.7 volts or 1.48 volts. This is for the nickel metal hydrides. Tolerances are at 1% claimed, so that's pretty good. So in quick charge mode, we can either charge one cell at 3 amps or 2 cells at 2 amps each. So that's 2 amps on 2 cells is pretty good. Or we can charge at 1 amp if we charge in all 4 slots at the same time. Now that's in the high speed mode. So in standard mode, it charges 1 cell at 2 amps, 2 cells at 1 amp each, or 4 cells at 500 milliamps each. And actually this is good because the standard mode, this will prolong your battery life extensively. We have CE markings, FC, and it's made in China. So yeah, let's yeah, we have one side left actually. So do we find anything interesting here? Well, we have some standard claims. Compatible with the lithium-ion and nickel-nickel hydride nickel-cadmium batteries with automatic detection. Automatic detection of battery power level and automatic selection of the appropriate voltage and charging mode. LiFePO4 and 3.8 volt lithium batteries excluded. Yeah, so that's pretty standard. If you're using LiFePO4, for instance, then you have to select that manually. Automatic selection between 3 charging modes: constant current, constant voltage, and delta V, delta T detection. That's for the cutoff for detecting, for instance, when a nickel-nickel hydride cell is finished. Energy efficient LCD display, real-time charging information, capable of manually selecting the charging cutoff voltage and the charging current. So automatic detection of large or small capacity batteries and automatic selection of appropriate charging current. Reverse polarity protection and short circuit protection, over discharge battery activation, lithium-ion battery restoration, overtime charging protection. Automatic detection of battery internal resistance and display of battery health. That's interesting. See how that would work. Yeah, very durable and fire retardant PC materials, polycarbonate perhaps. Optimal heat dissipation design, certified by CE, FCC, and CEC. Insured worldwide by Ping An Insurance Company of China. Okay, so I can't wait any longer. I want to open it and see what's inside. So let's put the box aside. And what do we get then? We get a USB, micro USB lead, so it's not USB-C. And that's a bit of a shame, of course, in these days. We get a manual with very fine print. I suppose it says mostly the same things. Perhaps we get some instructions for proper handling. And then to the main event. We get a business card or a warranty card, and then the actual charger itself. So regarding the heat dissipation design, I believe this is plastic, and these are not cold to the touch, so maybe they're plastic as well. And plastic doesn't really conduct heat very well, but okay, maybe it doesn't need a lot of heat dissipation on the other hand. So there are no ventilation holes that I can see other than here on the bottom that actually are holes. So yeah, this is the UMS4 charger, and let's peel these off, and let me try to get a good peel here. Yeah, that's why we buy stuff, to peel stickers off of shiny surfaces. And yeah, so put this aside. I will attempt to use the included cable, USB lead, because that's what it was supplied with. So I hope that means it's the best cable for it. It should be able to supply it with the highest amount of current. As needed. So yeah, this is what it looks like, and yeah, pretty nice. We have two buttons, C and V. So, and here we have the input. So let me try to find a decent charger, because that is not included, of course. And we shall see what happens when we turn it on. Alright, I have searched the premises here a bit, and I found a couple of interesting things that we could try. So, first of all, I have a power meter. I'm going to connect it, and we can see how much power we are drawing. I have this 2-slot Belkin charger, and it is a 24 watt, so it can handle 5 volts, 2.4 amps, which is more than this one required at a standard charge, for a standard charger at 5 volts, 2 amps max. And then I have this key QuickCharge enabled charger that says 12 volts 1.5 amps or 5 volts 2 amps. So this one should enable the Nitecore UMS4 to utilize QuickCharge 2.0 for a total of 18 watts. So we're gonna try if that works, and I'm gonna monitor the power usage. So yeah, we're gonna start off like this. This there. Okay, so I shall just plug it in. Alright, so the charger has been turned on, and a couple of minutes have passed. I want to wait to see if it will dim the screen, and it does. So after a couple of minutes it dims down. If I press a button, it returns to its highest display backlight setting. So what do we see then? Charging status, charging mode, and empty cells. So yeah, and I have checked the manual a bit, and it says regarding the internal resistance detection that it will show it as good if it's below 250 milliohms, and poor if it's above 250 milliohms. So we'll see if does it only display good or bad, or does it actually display the internal resistance value. So what should we begin with? Well, right now we're connected to the standard 5 volt 2.4 amp USB charger, and my watt meter is displaying 0.0 watts. So perhaps this is such a low power draw now that is below the minimum of the watt meter. So I have 4 Chinese rechargeable nickel metal hydride cells here. I believe this should be discharged, but let's find out. This charger should tell us. Let's put it in the first slot. Okay, right now nothing is happening. I suspect we don't have a very good connection here. If I rotate the battery a little bit, we get connection. Whether that's due to the battery having bad connections, or terminals, or the charger, well, I don't know. I mean, these are spring loaded, but yeah, they seem to be decent, but I mean, or a double cell is long enough for it to get some tension, so it should have good contact. Okay, so it says it has identified it as we're currently on slot 1, and then we'll see charging mode, nickel metal hydride or nickel cadmium, delta V delta T detection mode. We're charging at 996 milliamps, which is an interesting charging current, but basically 1 amp. We can see the battery is pretty empty. So far we have accumulated 25 milliamp hours into the battery, and it says poor. So we have 1.36 volts currently. We're 3 minutes into a charge, and if I short press the V button, I can cycle these values on demand. And what if I short press the C button? Nothing happens, and that's because the C button, it cycles through the slots, and we only have 1 cell. So let's insert a second cell. This one made better contact from the start, and we can see that now it is displaying the values for slot number 2. Also poor with regard to the internal resistance. And we have 1.29 volts, 0 minutes into the charge. Oh yeah, sorry, it does say 500 milliohms. Yeah, that's me being a bit blind as to what I'm looking at, perhaps. So 500 milliohms. And we're up to 1000 milliamp of charge current. So let's cycle back to first slot. Okay, it's it showed briefly something about slot 4. Was it because no? Okay, strange. First slot, let's see here, 500 milliohms as well. Switching to slot 2, 500 milliohms. Okay, so maybe it doesn't show the exact value. I find it very odd if both batteries would show exactly 500 milliohms of internal resistance, but maybe it's in that range. So it's not 250, it's not below 250, and it's closer to around 500. But I suppose at least we get some kind of indication then as to the order of magnitude of the internal resistance then. So okay, that's better. I can live with that. Let's insert a third cell. And it also shows poor, but 3. Okay, wait a minute. That's interesting. So this battery is a bit more charged than the other ones, but this is at 318 milliohms, so it's showing a specific number actually. Maybe it's showing if below 500, maybe it's showing the actual value it measured. I don't know. Okay, but that's good. And let's see here. 994 milliamps. $827, 998, 905. Okay, so I believe that what did the box say? Well, it didn't say anything about having 3 cells. But in standard mode, 2 batteries at 1000 milliamps, 4 at 500 milliamps. So 3 is perhaps also at around 1000 milliamps each. So let's insert the 4th cell. And okay, the 4th slot shows E, so that's perhaps stands for error. So is this battery really bad? It immediately goes to the error state. Okay, so let me try to remove the first cell. It's not warm to the touch, it's about finger warm. And let me insert that into the fourth slot. So this one identified it incorrectly as a lithium ion. So that's not good, since this isn't a lithium ion cell. Let me try that one more time. And now I lost contact on number 2 here. Maybe these batteries, the terminals aren't very good. So let me try again. Alright, so this time it actually identified the fourth slot as being a nickel metal hydride. And charging it accordingly. And let's take the first cell, or take the fourth cell I had and put it in the first slot. And it shows error immediately. Okay, so the error is not in the slot itself, but in the battery perhaps then. And why it has an error, I'm not sure. We should perhaps check the voltage of the battery. But yeah, I'm a bit concerned that when I moved the first cell from the first slot to the fourth slot, it identified it as being a lithium ion cell and started charging it at 4.2 volts, which isn't the proper charging voltage for nickel metal hydride cells. And yeah, even though the battery is in poor condition, it shouldn't become a fire hazard just because of that. So yeah, I'm not sure how often it will misinterpret the type of cell inserted, but I certainly don't like it wrongly identifying the battery. So yeah, but let's sorry. Yeah, we don't have very good contact here for this cell, but let's keep it in cell 2 here. And what can we do more? Can we change the charging current, for instance? So let's explore that. But before that, let's check the manual for what the E's meant. And I see that there are E's here. It says that if there are batteries inserted with polar, reversed, or short-circuited, the screen will flash to show E. So that cell was either reversed in polarity or short-circuited. So yeah, okay, but let's move on to see what we can, what settings we can apply. Okay, so if I long press and hold the C button, now the charging current is flashing. I can use the V button to increase it in 100 milliamp steps. So that's nice. That's a pretty fine grained adjustment. So let's see how high we can go. We can go from 300 milliamps. Yeah, and with 100 milliamp steps all the way to 2000 milliamps. And if we are happy, I suppose it's said in the manual we should long press. No? Yeah? So, yeah, now we're increasing closer to the set 2 amps. So long pressing the C button saves the settings. It isn't exactly at 2 amps, but it's up there. Perhaps it considers that the battery has high internal resistance also. So we long press C again. Let's choose 300 milliamps. Press the V button a couple of times. Yeah, we're down to 302 milliamps. Okay, so what else can we do? Apart from setting the charging current, we should be able to set the cutoff voltage as well. And that is a pretty interesting thing. Let's see if it works for nickel metal hydrides as well. So long press C, short press C. Okay, so for nickel metal hydrides, nothing seems to happen when I'm in the setting mode and short press C. So I don't seem to be able to set the cutoff voltage. However, long pressing the V button in this settings mode, you immediately get the maximum setting, and then we can long press C to save the setting. Yeah. Okay, so we can set the cutoff voltage for nickel metal hydrides, which is a shame, perhaps. If you don't want to charge them fully, nickel metal hydride cells, at least new ones, shouldn't have any memory effect, and like nickel cadmiums had, and perhaps the first generations of nickel metal hydrides. I'm not sure, but it seems to me that being able to set, for instance, 1.4 volts as cutoff, or 1.45 or something for nickel metal hydrides, it would be nice to be able to do that. Okay, and now we are actually slowly creeping up to 2000 milliamps. So yeah, okay, but that's pretty neat, and being able to control the charging current in 100 milliamp steps is actually pretty nice, and doing so per slot. So okay, so I wanted to see here if I insert. Okay, that battery is dead, but does something work on a dead battery? If I press long press C, nothing happens. If I press V, nothing happens, except it toggle or switches between the showing the different values, but they're all zeroed out or error. If I long press V, yeah, if I long press V, something is happening. We have now a display of 0.16 volts in slot 3. It shows error. but it did try something. So let's see what the manual says about it. Okay, so interestingly, the manual only mentions over discharged lithium-ion battery activation, and in that case, it's capable of activating over discharged lithium-ion batteries with a protective circuit. After battery installation, UMS4 will test and activate the battery before charging. When a battery is detected as damaged, the screen will show E. Okay, and IMR battery restoration. So when an over discharged IMR battery is inserted, the screen will show E. In this case, long press V button to enter restoration mode, and that's exactly what I did. I long pressed the V button, but on this nickel metal hydride cell. After that, let's see here, the charging process will continue. The battery should be replaced if it fails to be restored after several attempts. Note, when attempting to restore an IMR battery, reverse polarity protection is temporarily disabled. Please ensure batteries are correctly inserted. Failing to do so may result in fire or explosion. Yes. So I suppose it disables polarity reverse protection, because if the battery is at 0 volts or so, it is basically short-circuited or something, and it has to just try to charge it anyway. So the battery better be in the right, inserted with the right polarity. But it doesn't. The manual doesn't say anything about restoration of nickel metal hydride cells, but it does say several attempts. So let me remove this second battery, so we can concentrate on this erroneous third one. And the manual mentioned several attempts. And it will try now for a little while again. We can't see any more info while it's doing that, but I will give it a few tries. As long as the voltage keeps creeping up, at some point, if this continues, it should identify that this is an actual cell. So error again. I will give it another try. We're up to 0.4 volts already, and it's creeping up. Yes. All right. Once reached about 1 volt or so, the charger identified that oh yes, this is actually a nickel metal hydride battery. However, it is poor, and it says 360 milliohms. But considering the fact that it immediately jumped up to 1.48 volts, meaning it's almost fully charged, yeah, the battery seems to be in pretty poor condition. But it charges it at 1 amp, and so far it is taking a charge. So what if I remove it and insert it once again then? For instance, in the first slot. Okay, so now it's showing good at 131 milliohms, 1.44 volts. So it's a bit interesting that the battery was dead at 0 volts, it seems, or close to it. After several restoration attempts, it at each attempt it tried to restore the battery by pushing some charge into it, and the voltage kept creeping up, and we got to a voltage where it could identify it as being an actual nickel metal hydride cell, but it displayed 360 milliohms and said that it was poor, and the battery was immediately at 1.48 volts. Then we removed the battery, inserted it in the first slot. We got a slightly lower voltage, 1.44, and suddenly a good internal resistance of 131 milliohms. So unfortunately I'm not a battery chemistry engineer, and I can't tell if this is expected behavior, if this is normal behavior, or if it's just not a too accurate charging circuit for detecting the internal resistance. Maybe it's not that easy. Okay, but the battery seems to be taking a charge of 1 amp. So if I now insert all 4 cells, let's see what charging current we'll get for each slot. So yes, first slot, 0 milliamps. Okay, no, 1 amp. Okay, second slot 1 amp, third slot 1 amp, fourth slot 1 amp. Okay, so almost. Okay, it's a balancing according, I suppose, to the available input current. And checking the watt meter, I can see it showing 7.3 watts or 6.77 watts, 6.9. So we are between, yes, 6.8, 6.5, 7.3, yeah, pending there. Okay, so what if we have 4 batteries? What's the highest current we can set? So I will start with the first slot here, long press C, long press V, 2000, and long press C. 1.8 milliamps, or 1.8 amps rather. Yeah, so what are the other ones then? Yeah, the second slot is decreasing in its charge current a bit, but the other ones are staying where they are. So let's try to increase to maximum on sorry, did I? Yeah, let's go in here again, 2000, save that, and let's see if it actually does that or not. Well, we'll get 1.5 at least amps. Yeah, we seem to stay at 1.5. 1 amp, 1 amp. Okay, so we decreased at the first slot to 1.27. 1.26. Okay, so it is balancing depending on which slots you prioritize for higher current. So if we set save, 440, Okay, so that actually decreased. Now then, let's set this to maximum as well. So now all 4 slots have been set to the maximum of 2 amps. Let's inspect 1.7, 1.3, 1.5, and 1. So we are drawing quite a lot of current. And if I check the watt meter, previously we were at around 7 watts. Now we are at 9.2, 10.3, 8.5, 9.1. Okay, so we are drawing more power. And 5 volts at 2 amps would be 10 watts, which is what the charger that I have connected should be able to handle without any issues. In fact, it should be able to handle 2.4 amps, but the charger itself, the battery charger, is rated at 5 volts, 2 amps. Okay, so we are at 1 amp. Let's see here, 1.2, 1.447, 9 and 2, 1.6. So it seems to be balancing them a bit, perhaps depending on how fully charged they are. So we're at about between 8.5, 9.3, 9.5 watts, sometimes hitting 10 watts. What I would like to do now is to change the charger, the USB charger that is, for this Aki QuickCharge 2 enabled charger. So this should be able to output 18 watts, 12 volts at 1.5 amps. So let's try that and see what happens. Like that. A bit hard to insert the plug. One moment. Alright, the new charger has been connected, and we got a new text here being lit up saying QuickCharge. So it has successfully identified that we are QuickCharge enabled. So that's good. So yeah, and this time I noticed it says this 4th cell is good at 233 milliohms. What about this one? Good at 112. Wow, so it's improving. 2nd cell is 210. 3rd cell is poor, 395. So it is a little bit random, perhaps, from time to time. But I suppose, yeah, I don't know. If it repeatedly shows good, then it's probably good. If it has shown poor at some point, then perhaps the battery is poor, and yeah, it doesn't seem to be that decisive of a reading. So right now we are at 1 amp for each slot, so 4 amps we're drawing, and 8.5 watts I'm seeing on the watt meter. So let's once again try to set the maximum value for each slot. Saving, and then going to the next slot. Okay, so now we have set 2 amps. We have 2 amps on the first, 2 amps on the second, 367 on the third, and 2 amps on the fourth. Okay, let's check the third again. 1.2, so we're increasing there. We're maintaining 2 amps on the other slots. 1.235, yes. And now the watt meter is showing 16.3 watts. It was just recently now at 12, then 14, 13, then 16. So we do have a higher power draw, meaning that it does utilize the capabilities of the other QuickCharge enabled USB charger, in fact, which is good. It means it's working, but the charge current seems to be pending a bit, and we're drawing anything from 11 to 16.2 watts. Okay, so oh my, this video is quite long already, but it's an interesting charger, and we have to explore its capabilities, right? Okay, so I have a couple of other things I would like to try. So let me remove these batteries. Having this single cell left here at 2 amps, we're drawing 8.4 watts at the wall. Okay, so let's try these 18650s. This should be pretty discharged. Yes, lithium ion 4.2 volts is identified in slot 1, good at 99 milliohms. And I believe these batteries are good. I haven't had any issues with them so far. Currently 3.52 volts. We have charged 10 milliamp hours already. And the charging current is 2 amps. And we are drawing 11.3 watts. So the difference between 2 amps for nickel metal hydride and 2 amps for a lithium ion is that 2 amps at around 1.4, 1.5 volts for these is of course less power than 2 amps at 4.2 5 or 4.2 volts or so. So therefore we have a higher current draw. Even at one cell. Okay, so let's insert the second cell. What if we insert it in the fourth slot? Yep, no problems there. Also, it's identified as lithium ion 4.2 volt. We are in fact in constant current mode, which we are on the first slot as well. So right now we're keeping the current at 2 amps constant. I suppose that once the battery is closing in to being fully charged, it will switch over to constant voltage mode. Or I don't know, yeah. We will see. And also at 2 amps. So let's see what we can do. If I go into settings, yeah, the maximum is 2 amps. So it sort of remembered the setting. Okay. But can we set the cutoff voltage for these cells, since we're at lithium now? So if I go into settings, yes, now I can choose lithium ion at 4.2. Maybe I switch with these 4.3, or lithium ferrum phosphor at 3.7. Okay, so that's what I can choose. And hold to save. Okay. Sure. So now I'm actually drawing 22.2 watts according to wattmeter. So I should be able to draw about 18 watts, or the charger should be able to supply 18 watts of charge, of power. So, but let's check these ones out. These are rechargeable 16340s, and these are 3 volt ones, so this should be LiFePO4, and we should have a cutoff voltage of 3.7 on these and not 4.2. And as the manual says, that won't happen automatically for these this battery chemistry, so we have to set it manually. And let's see here if the tension on the terminals here will be enough, the spring-loaded mechanism, to get a good contact here. Yes, it identified it, but it identified it as a 4.2 volt lithium ion. So let me long press C, press C again. So pressing V, we can choose LiFePO4. Yes, so now we're at LiFePO4 here, but the charge current then is 1 amp, which is a bit high for a cell with a capacity of 500 milliamp hours. So I would like to change that. For instance, to 300 and save. Let's cycle through and see. Yeah, 311 milliamps. And we can do that, I suppose, on the second battery. So once again, long press C, press short on C again. we get into the mode where you can choose the chemistry, cutoff voltage. LiFePO4 is flashing, 3.0 volt cutoff. Long press C to save. Oh, but we want to change the charging current as well. We don't want 1 amp here, so long press C, and then we'll cycle through to 300. Let's say 400. Long press C to save, and let's inspect if we got 400. Right now 26 milliamps. 400. Okay, so it's stepping it up. The fourth cell is still at 2 amps. First is at 2 amps. Second is at 315. And third is at 400. So, yeah. Basically, if you pay attention, I mean, this is a sort of advanced charger. It's not for the typical IKEA charger buyer sort of target group, I suppose. It's for those who want to monitor and control the charge of their batteries. Alright. All well so far. The only part really that I'm so far not too pleased about is the fact that the internal resistance is showing a wide it's showing a wide range of values for the same cell from time to time when disconnecting and reconnecting the cell. Sometimes it's good, sometimes it's bad or poor, and yeah, I don't know. It seems a bit indecisive. So at least for me as a user, it doesn't make it too easy to know if the battery is good or not. But of course, yeah, if like one of these cells was at 0 volts at the beginning, that's not a good sign, even if it shows first poor and then good afterwards. So I wouldn't use these batteries, for instance, in high drain environments, like some remote controlled toy car or something like that, for instance, which has an engine and a motor, electric motor that draws a lot of current. But these work fine for a couple of months or so, at least, like in a wireless computer mouse or keyboard or stuff like that. I've been using these in mice, and it has worked okay. So I have one last test I want to do here, and it's these ones. So I have a good brand, C size, nickel metal hydride, 3000 milliamp hour cells, so we should be able to charge them at max current for this charger. They are pre-charged. They have been lying in a drawer for 3 months or so, 4 months perhaps, and they are new. So I'm thinking ready to use, but I want them fully charged at this point. So I will open them, and we shall try to charge them and see how well will they all four fit here in this size. We have, of course, D-sized batteries as well, but let's try these first. Alright, so The reason for using these batteries is that I have an outdoor motion triggered floodlight, and it takes 4 of these, so I want them fully charged because it's a bit of a hassle to replace batteries in that floodlight. Okay, so let's see how we can fit these. If I start with the first slot here, .39 volts, so these have held up okay, even in lying in a drawer. Good at 120 milliohms, so they are new, so they should be good. 1 amp current, metal hydride. Alright, fine. Yeah, it did fit right up against the second one here. And also 120 milliohms of internal resistance. 1.29 volts, a bit lower voltage than the first cell. Currently at 21 milliamps of charge current. This should ramp up, I suppose. No, 15 milliamps. Why is it at 15? Is it because we had this slot set to 300 previously, the lowest setting? Let's oh, wait a minute. It says full and 2.58 volts. That isn't what I would expect. So let's try that again, shall we? Okay, so now it actually 75 milliohms it's showing. 1 amp. Okay, so had some strange behavior there. It's 15 milliamps of charge current first time, but perhaps and it showed fully charged once I long pressed C to get into the settings menu. So if I try that again, I long press C. Okay. Long press V to get to the maximum. Long press C to save. Yeah, 2 amps. Okay. Very odd. So yeah, some sort of instability in as far as the operation goes here. Let's insert the third one. Ooh, we got some ease, but the battery did disconnect briefly. Now the first one is saying full, but we do have some issues because if you can see here, this battery won't fit. The positive terminal isn't touching the terminal on the charger, so it can't really fit 4 C-sized cells at once, it seems. And then once I was trying that out, the first battery is showing now 3.4 volts and full. So perhaps it got moved a little bit, and therefore it had a bad connection or something, and then it misinterpreted the battery charge. So yeah, But hang on a minute. I had to fetch a power bank to plug into my phone that I'm using to recording this. I'm recording on a Huawei P20 Pro, for those interested. Okay, so let me briefly disconnect this and reconnect it. Yes. Okay, so it's a bit of a shame that it is so sensitive. And now it also, once I reconnected the battery, it says poor and 473 milliohms. So if I disconnect it again and reconnect it, (1.52 volts), 417 milliohms, 1.52 volts. So I'm not really sure what is going on here, why it's behaving like this. Sorry. So let's try again, but we'll use 2 cells in the first and fourth slots so they don't touch each other, because maybe they are pushing each other away from the terminals on the charger. Okay, 94 milliohms, good. 1 amp. Now let's take this one in the fourth slot. And what are we seeing then? 44 milliohms, good. 1 amp, 1.3 volts. And let's change it to 1.5. So we're charging it 0.5 C, since the total capacity is 3000 milliamp hours on these batteries. And we'll do that for the first slot as well. Okay, 1.5, 1.5, 1.31 volts, 1.35 volts. So yeah, and basically for these size cells, I suspect you can only use the first and fourth slots. So yeah, because they do interfere with each other a bit. So I would rather actually have seen Nitecore making this charger a bit wider. I would have liked to see these fins here be not in plastic, but in something heat conductive, if that's needed to remove the heat. Because having fins that are of plastic, I don't know how much that actually helps, since plastic isn't really a conductor of thermal energy, as I understand it. Starting with the drawbacks then, to finalize this very long video. But hopefully this video has been extensive, and that you have been able to get the information you need to make an informed decision on either buying it or not buying it, or just watching it for fun, comparing different chargers. So yeah, I mean, the price of this, the base price is, yeah, what was it, about $32 on AliExpress. It did validate, at least on Nitecore's website, with the QR code sticker as genuine. So let's start with disadvantages. So first of all, the internal resistance measurement. It's a bit shaky, showing very different values pretty much each time. So you have to disconnect, reconnect a couple of times to see sort of an average value, and make sure you have good connection between the terminals, because I suspect that that might as well influence perhaps not only the voltage reading, but the measurement of internal resistance, as it seems to me from having used it now the first time out of the box. But having said that, I like the display. It's clear, it's informative. We get the accumulated charge, we get the charging time, we get the internal resistance, charging current, voltage, yeah. We have QuickCharge possibilities. So given that this charger has USB output, or input rather, only, we can of course plug it into a computer if we're traveling, or to a power bank. If we have a fully charged power bank with us and we need to charge these type of cells, it's not very efficient perhaps to do it that way, but you can connect it to pretty much anything, and I suspect this will draw as much current as it is able to from that USB port. Yes, and of course you can combine for instance 2 C cells with for instance I should be able to charge these LiFePO at the same time. Let's try that. These shouldn't interfere with they don't touch those cells. So we have to long press C, press C again, choose LiFePO, charging current 300, and save. Oh wait, no, it switched to, okay, I couldn't set both. Wait a minute. 1.5 nickel hydride. Okay, so it's switched. LiFePO 4, but 1 amp. Okay, so I have to 300. Okay, and then insert the second LiFePO. So if I set it to max, and then I can press yes, quicker to go to 300 that way. Yeah, now I can stay at the same slot and set both settings at the same time. 16 milliamps, 300. Okay, so 1.5, 1.5, 311, 312. Okay, LiFePO 4. Nickel hydride, LiFePO 4, LiFePO 4. Okay, so yeah, and of course we did see some strange quirks with these batteries. Suddenly they showed a high voltage, that they were full, maybe we didn't have a good contact. So I would have liked to see a wider charger which would be able to accommodate up to these size cells without them touching each other or interfering, so that we don't get any issues when trying to insert or remove cells. And but on the other hand, okay, it's quite compact, and perhaps if you are mostly interested in charging cells of a thinner type like 18650s and usual AA, AAA nickel hydrides, then 16340s, then sure, then that's no issue. But also it's lacking 9-volt battery support. I mean, it's if you're not using 9-volt rechargeable cells very often, then perhaps it's no big deal. But if this is your only charger, if this is going to be your only charger, then if you want to be able to charge 9-volt cells, then you're out of luck. So from that perspective, it just seems like a shame, because you want to have a perhaps a good brand charger with all these monitoring and settings and display, and you buy it, you spend some money on it, and then you still need to buy another one, either a dedicated 9-volt charger or another charger that can handle 9 volts as well. So from that perspective, I'm a bit disappointed. And the fact that it also identified once a nickel metal hydride cell as being a lithium ion cell, it seems like a possible fire hazard, because it in that case would place a 4.2 or 4.5 volts over the cell, and nickel metal hydrides aren't designed to have that kind of voltage applied. But on the positive side, then, like I said, it is a nice charger. I like the display. Especially I like the be able to set each slot individually with 100 milliamps of charge current steps. That's not often I've seen that on chargers. So if you're really looking to, and you can start at 300 milliamps. I believe the X-Star VC4 charger that I showed previously, I believe it had either a 500 or 1 amp setting, basically. So if you're charging 16340s or AAA cells, or even quadruple A cells, there are rechargeable quadruple A cells. This is not officially supported, but I don't see why it shouldn't be able to charge quadruple A cells. You can set it to 300 milliamps, and it should be just fine. Yeah, you only have 2 buttons, and it's easy to set the settings. After trying it out a couple of times here, it was like second nature to navigate. So yes, what's the final verdict then? I mean, I do like the charger, don't get me wrong. I do not like some aspects of it. Will I be using this as one of my main chargers? The answer is yes. Why? Well, basically because of especially the possibility of the fine-grained charge current control, and then the display, of course, and being able to monitor and being able to charge all the chemistries of batteries that I have. But I also do charge 9-volt cells, so I will have to use other chargers as well. And if I want to charge C or D cells 4 at a time, because now these ones have to wait here for a few hours perhaps, and then I will have to wait a few hours more to charge the other two. So it's not perfect, but for someone who likes being able to monitor and control the charging of your batteries, it's a pretty nice charger. Just remember to, especially at the moment of connection and while it's identifying the batteries and stuff, be sure to check that, double check that it has identified the battery correctly, you have the correct setting on the charging current you want, and yeah, make sure it is stable in the charging because of the little quirks we had here. Alright, so this is it for the review and look at the Nitecore UMS4 battery charger. I hope you have enjoyed it. I have definitely, and thank you so much for watching. If you have any comments, please leave them below and support my very small channel if you like. That's greatly appreciated, of course, but don't feel any pressure at all. I'm not doing this because of that. I'm doing it because I enjoy this, and I would like to share my experiences and help you out in your possible buying decisions. So I hope you have enjoyed it. I have. Thank you so much for watching, and I will see you in the next one. Bye bye.